Thank you for having me today. So I am Noshira binti Mazahar and my supervisor is Dr. Fedawati PhD Wong and my co-supervisor for this project is Dr. Yong Sung Kong. So for today, I would like to present on the proposal presentation for development of polypropylene with fly ash composite for pavement application. So for the introduction, as we all know, nowadays there is a lot of waste plastic that is not being recycled. Thus, it can give pollution to this world. And based on the WWF, it has been shown that average Malaysian use 16.78 kilogram of plastic packaging each year, and only 15% of the rubbish generated in Malaysia is collected. So, there is 1% of polypropylene that is being recycled, while the others will be buried in the landfills. The recycling process affects the PP on the thermal degradation, which affects the intensity structure of the bond between the carbon and the hydrogen, and it will become more weaker. So, in this case, PLA is needed to improve the recycled PP in order to develop a new product. So, actually, um, in polypropylene, there is toxic additive, which is known as cadmium and lead. So, this will cause harm to the environment, and if the soil absorbs the toxic that uh, include in the polypropylene, it will give harm to the aquatic creature. This is because the water from the soil will be flow into the river and the ocean. So next, in this study, fly ash had been chosen to act as the filler into the PP bond to reduce the limitation of the recycled PP in thermal degradation factor. So before, coal-based power station cast away all the fly ash in returning strip mine or burying it in the landfill. So this can contribute to health hazard because of the presence of the toxic metal in the fly ash. However, this can be solved if we use the excess fly ash to produce a new material that can replace the available material for construction that is more efficient in cost. So this project had become one of the initiatives to solve both of the material that can reduce the pollution in the environment by recycling those materials and develop those as a new product, which is pavement. So next is the problem statement for this project. So the polypropylene will undergo thermal degradation when the recycling process occurs. The molecular weight and the chain length of the polypropylene will be decreased as the thermal degradation causes chain scission in the polymer. So this will affect the mechanical properties of the polymer, such as the stiffness, the ductility, and the brittle of the polypropylene. So this polymer can be preserved from thermal degradation by synthesizing with the filler into the recyclability, which is in this project we use fly ash. So the filler will fill in the polypropylene matrix and remain the polymer chain and molecular structure of the polymer. So most of the studies that had been researched before, most of the study only highlight on the temperature that is needed to improve the mechanical and thermal properties of the composite. But there is no studies that highlight what is the best ratio that can produce a composite that have good uh, in mechanical and thermal properties of the composite. So the objective of this study is first to check the thermal characterization of PPFA composite by TJA and DSC, then to investigate the microstructure of the PPFA composite through scanning electron microscopy (SEM), and to determine the tensile strength, elongation, hardness, and fatigue limit of the PPFA composite through the tensile and compression test. So next is the literature review. So overall review of polypropylene. The origin of polypropylene is from the thermoplastic, which is usually multifunction in various industries, such as in automotive industry, in food packaging industry, and in medicine. Uh, because in medicine they use polypropylene to produce the uh, bottle for the medicine. And then, based on the figure that had been showed in the slide, we can see that there is largest production for PP in 2018 compared to the other polymers because polypropylene can be used in various applications. And then the recycling propylene techniques. So most of the techniques that we use to recycle the polypropylene is mechanical recycling process, chemical recycling process, and thermochemical recycling process. But in this case, PP had been recycled through mechanical and chemical process due to its ability to be melt and mold. So in thermoplastic molecular chain, there were no strong secondary bonding like hydrogen bonding or cross-linking because polypropylene was a linear structure where the molecules had together via van der Waals bonding. So when this material introduced to heat, the weak bonding was easily ruptured due to high frequency or molecular vibration and increment of kinetic energy. So this will make the molecular freely to movable and easy to be reshaped and moved. So next is the structure of PP before and after recycle process. So the post-consumer plastic waste may contain many polyolefin grades, colors, additive, processing aids, reinforcement, and contaminants, leading to varying outcomes when these are employed for future application. So the molecular weight, crystalline structure, and cross-link characteristic of PP change during the recycle process, which also can give a significantly change in the mechanical properties. So the modulus and hardness of PP will significantly increase by mechanical recycling, but the tensile strength will be decreased. Then the decrease in molecular weight, this phenomenon may also cause the surface hardness of PP to increase unexpectedly with the number of re-extrusion cycles. So next is polypropylene composite. So in this study, we had studied 3 types of composite, which is PP natural fiber composite, PP mineral composite, and PP fly ash composite. So for the PP natural fiber composite, the natural fiber is often being used as the pillar in the polymer matrix in order to produce the biodegradable polymer composite. So in this case, we use knaf, bamboo, hay, sisal, ham, and rice. And then lignocellulosic fiber that being found in the natural fiber have a great affinity in moisture absorption that may cause a bad impact on the dimensional stability of the polymer with natural fiber composite. So to solve this problem, modification of natural fiber is required. So based on the literature review that had been made, some of the research had used sodium hydroxide to make surface modification on the natural fiber. So according to Rindusit, he stated that particle size of the wood flower that's suitable to improve the mechanical properties was between among 200 to 300 micrometer. But if we use more than 300 micrometer, the flexural and the tensile modulus will be decreased due to the surface area polymer weighting for the large size particle is less. In a result, the load transfer between the large size filler and the polymer matrix. And then addition of PPG-MAA is no solution to improve the interfacial addition between the natural fiber and the polymer. So based on the study, we showed that the presence of the coupling agent can enhance the mechanical properties of the composite. So next is the polypropylene with mineral composite. So Zai et al. Report that by using mineral as the pillar in PP matrix, it has shows that the hybridization of the AT in the composite enhance the mechanical properties of the neat PP. So the figure shows the difference of tensile fracture, which is A and C shows the tensile fracture for the untreated AT-PP composite, while B and D figure shows the treated AT-PP composite. So in this case, it will be showed that by adding mineral into the polypropylene matrix, it can enhance the mechanical structure or the mechanical properties of the polymer. So next, polypropylene fly ash composite. So in Europe, fly ash recycling has been extended to road construction. However, the material used for road construction still include the aggregate and the cement to enhance its strength. But in this study, in this project, we try to see for a solution which we would not use the aggregate or cement to enhance the strength of the composite. We just use polypropylene and fly ash. So due to the low surface fraction of fly ash, interface bond between untreated AT is weak. So the introduction of FA as a pillar to improve the composite is problematic. So in this case, we need a coupling agent to help the dispersion of ash particles in the PP matrix. And next, we will look at the methodology. So this is the flowchart of how we prepare the composite. So next is the composite preparation. So first, the mixing process. With polypropylene and fly ash will be mixed in the TSE machine at a ratio of 100 to 0 and 80 to 20. So the machine runs at a speed of 60 RPM with 200 degrees C. So for the first sample, we use 300 grams of the mixture. We put it into the hopper of the TSE machine, while for the second, until the last sample, we only use 200 gram of mixture because we want to save the mixture that we have. And then when the product has been produced from the TSE machine, it will be cut into small pieces. And then for the compression process, only 60 gram of the mixture that has been produced of each ratio will be used to be compressed by the hot press machine for 5 minutes with pressure of 200 bars under 200 degrees Celsius. So the mixture will be put into the square mold. So the figure shows the dimension of the square mold, which is 15 centimeter of height and length and with 3 millimeters of thickness. Next, testing. So the testing that we made for this composite is tensile testing and compression testing. So for the tensile testing, we use ASTM D638 as the reference for the shape and size of the specimen, while the compression testing, we use ASTM D6641 for preparing the specimen in shape and size. And then we also do thermogravimetric analysis, TGA and DSC on this specimen. For the TGA and DSC, we will analyze the recycled polypropylene and also the pure resin. So next, the expected result. So based on the slide that we showed, there is a table. Actually, this is a preliminary result that we had gained. But this result obtained from the tensile test are not reliable because the result pattern is not constant. This problem may be caused by the number of samples tested. We only use 3 samples for do the tensile testing. Actually, to get the best result, we need to use 5 samples to be tested. So that is the factor why the result is not reliable. So the second factor is the equipment used to prepare the sample is not proper because during the preparing of the sample, we only use the handsaw to cut the composite into the dot bone shape. So it is not accurate. Actually, we need to use the cutting machine that have provided in the lab, in the workshop, to get a dot bone shape that is accurate. So it will not cause any defect or any not accurate result for the testing. So that's all from me. Thank you for your time and consideration. So if there is any requirement or question, you can contact me at email, which is shairamazhar.13@gmail.com. Thank you.